Hello everyone. Today we are going to discuss about benefits of smart grids. Last two videos we have been looking at smart grids. Smart grids is a basically advanced electrical grid where we use digital communication and automation technology to provide a communication channel together with a power flow, which means that any measurements like voltage, frequency, active power, reactive power, power factors, harmonics, all the measurements in real time, all the data will come to the control center, and all the communication from the control center to control the loads or control the power generation or the control the charging discharging of the battery. All the command also can be communicated from the power center to the generating station or the load center in real time. So that is the fundamentals of smart grids. So today we are looking at the benefits. What are the benefits? So we can look at what is a smart grids. We have connected with all the type of loads and energy resources, the power generating resources such as wind, solar photovoltaic, and all sort of generation and load together. So first benefits is enhance reliability and resilience. Smart grids can detect, isolate, and repair fault more quickly, resulting in fewer outages and shorter restoration time. So because of smart grids, as I explained in the early videos, like in a conventional way, when there is a fault, we usually go to that particular location and isolate the particular feeder or something from the fault occurrence place. So here in smart grid technology, by sitting in the control room, we can isolate the particular section of the power grid or the feeders or whatever the load, particular load, we can disconnect the particular load. So fault detection and repair is very quick, so that is a very good. We can reduce the downtime, we can restore in very fast, so that we can reduce the downtime. They provide the resilience against cyber attacks, as they can quickly isolate compromised section of the power. So because we can easily control and isolate the section of the power, so we can protect the system from the cyber attack as well. So second benefit is a better integration of renewable energy. This we have been keep on telling that renewable energy integration is a challenging task to do that, because renewable energies are not dispatchable resources like solar PV, wind power generation are not dispatchable. Not dispatchable mean we cannot expect the power generation whenever we ask, like diesel power generator in the night or day, whatever time if we ask, it will provide the power. But renewable power generation are not like that. So in that case, there are a lot of challenges in integrating renewable power generation. So the smart grids provide the make it easy, the challenges to become easy. So real-time monitoring and flexible infrastructure, smart grid can seamlessly integrate renewable resources like solar PV and wind. So seamless integration of renewable resources is a big research topic, because seamless means without any issues to existing grid, power grid. Because usually we have been talking about duck curve, because in the daytime, after daytime we are generating a lot of power from solar PV, but nighttime we are not generating. So there are a lot of mismatch, and there are like climatic changes, suddenly we cannot produce any power from the solar PV. So these kind of issues, like we had to manage in the real time, because it's completely depend on climate. The solar power generation is completely depend on weather and climate. So in that case, we have to monitor it real time. So real time monitoring is possible only through the smart grid infrastructure. The second one, this reduces the greenhouse gas emission. As we know that if we integrate a lot of renewable energy resources, the greenhouse gas emission reduce, because we are not renewable power generations are not generating any greenhouse gas. So that is the advantage of better integration of renewable energy. Next one is increase energy efficiency. Customer can monitor their energy use through smart meters. We have been heard about smart meter recent days, like from your mobile phone you can monitor how much power you consume today, how much power you generated by solar PV today. So these are the information is possible only because of smart grid, smart infrastructure. Actually, we are moving towards smart grid. By moving, we are doing this smart meters, IoT internet, IoT based devices. Actually, smart meters is a IoT based device. It's working in that way, and reduce a consumption based on dynamic pricing. So we have discussed about dynamic pricing, mean every hour or every minute we can change the price of the electricity, like a share market price or something similar to that. We can change the price of the electricity in every as a dynamic pricing. So that by doing dynamic pricing, which lower the bills, your electricity bills, customers' electricity bills will lower if you introduce a dynamic pricing, because customers know when is price is cheaper, then they use during that time. They wash their cloth when the price is cheaper, really cheaper. So utilities can optimize power flow, reducing losses and minimizing waste during transmission and distribution. Because if you know exactly how much power we need next hour, as a power system engineer, if I know exactly how much power needed next hour, I know I can send only that much amount of power. So I no need to waste any power. So usually we know, like for the peak power generation, we have the peak plant. Okay, a peak power plant. So in order to meet the peak power, we have to have a reserve, a lot of reserves. So a lot of reserves are wasted. Usually generators are running at 70%, mean another reserves we have a hot reserve. Some other generators we keep as a cold reserve. So if anything happen, we start that generator. So the reserve requirement is reduced because we are monitoring the power system in a real time. So we can have a more accurate prediction by this. So it optimizes the energy flow, optimizes the power flow. Then we can come to environmental benefits. Smart grids help reduce carbon emission, as we already said, by incorporating renewables, supporting electric vehicles, and improving overall grid efficiency. So, a lot of benefit. Electric vehicle, we can charge, discharge in a particular time based on the meter, smart grid data, and grid efficiency will increase. They minimize the need for fossil fuel powered peaker plant. This is why what I was telling, peaker plant, because we don't need to keep any power plant as a backup or a reserve to manage a peak demand, because we try to flatten the curve, because by doing this smart meter infrastructure, there is a demand management program. Customers knows when the price is cheap and high. So all sort of things is going on. So with that, we no need additional capacity to meet the peak demand, because peak demand itself is minimized by doing the smart grid infrastructure. Next is empowerment for customers. With real-time usage data, consumers have more control over their energy cost and environmental impact. Because consumer has more control, because you know the price, you know how much you are generating solar panels, how much you are consuming, what time is the best time to consume, all sort of data they have. Many smart grids support net metering, where consumers with solar panels or other distributed energy resources can earn money by selling excess power back to the grid. So you can see this dashboard. Usually, the smart with the smart grid infrastructure, data analytics dashboard. You can send this as a mobile apps. You can create every hour. This will display total energy consumption, but it's a price of this particular hour. All sort of things is a dashboard. We call the analytic, and from the data analytics we provide the dashboard. Okay, so the last one is economic saving. Efficient management and better outage response reduce operational cost. Total operation cost will reduce for utilities, translating into long-term saving for both provider and consumer. Because if the total operation cost is reduced, then everyone electricity price will be cheaper and everyone will get the benefit. Demand response and dynamic pricing help prevent costly infrastructure investment and by balancing demand more effectively. And that's why I said that if we introduce the smart grid, then the peak demand issue become less significant. So we no need to have a larger plants or huge infrastructure. So the because of demand response and dynamic pricing, we can reduce the infrastructure investment. We don't need to go for another huge power plant. We don't need to start up any huge power plant. We can manage all the things in very efficiently. So that's all for today. Thank you very much. I tried to finish it in 10 minutes. That's why in the last few slides I will little rushing up. Thank you. Please continue support this channel.